According to the National Electrical Code, Section 408.3h, underground installations under buildings shall be avoided. Furthermore, Section 408.3i dictates that where it is necessary to install underground conduit or cables under buildings, they shall be installed in rigid or intermediate metal conduit, rigid non-metallic conduit, Schedule 80 polyvinyl chloride conduit, Type UF cable, or other approved raceways. Section 408.3j states that the raceway shall be encased in at least 6 inches of concrete. Therefore, if a conduit is not encased in concrete and is not installed in an approved raceway, it is a code violation to bury it under a building. Burying conduit under a building presents several risks, including damage to the conduit, electrical hazards, and difficult access. Firstly, the weight of the building can crush or damage the conduit. Secondly, if the conduit is damaged, it can create a shock or fire hazard. Thirdly, it is difficult to access and repair a conduit that is buried under a building. Recommended actions involve rerouting the conduit around the new building. If it is not possible to reroute the conduit, consider replacing it with an approved raceway that meets the requirements of NEC Sections 408.3i and 408.3j. Always contact a qualified electrician for assistance. The code emphasizes the importance of protecting underground electrical installations to prevent potential hazards and ensure the longevity and accessibility of the system. Understanding the specific requirements for underground conduit installations is crucial for electrical safety and compliance. Let's delve deeper into each of these aspects. Firstly, consider the types of approved raceways mentioned in Section 408.3i. Rigid metal conduit, or RMC, offers robust protection against physical damage and is suitable for direct burial applications. Intermediate metal conduit, or IMC, provides a lighter weight alternative to RMC while still offering substantial protection. Rigid non-metallic conduit, typically polyvinyl chloride or PVC, is resistant to corrosion and is often used in underground applications, especially when encased in concrete. Schedule 80 polyvinyl chloride conduit is a thicker-walled version of PVC conduit, providing increased strength and protection. Type UF cable, or underground feeder cable, is designed for direct burial without the need for a raceway, provided it meets the specific requirements outlined in the code. Other approved raceways may include electrical metallic tubing, or IMT, when encased in concrete, or high-density polyethylene, or HDPE, conduit, depending on local regulations and specific application requirements. Secondly, the requirement for a 6-inch concrete encasement, as specified in Section 408.3j, serves to further protect the raceway from physical damage and environmental factors. The concrete encasement provides a barrier against soil movement, moisture, and the weight of the building, reducing the risk of crushing or damaging the conduit. The concrete also helps to dissipate heat generated by the conductors within the raceway, improving the overall performance and lifespan of the electrical system. Thirdly, when rerouting a conduit around a building, it is important to consider the path and depth of the new installation. The conduit should be installed in accordance with all applicable codes and regulations, including requirements for burial depth, backfill material, and protection from physical damage. The rerouted conduit should also be clearly marked and documented to facilitate future maintenance and repairs. Now, let's discuss the potential hazards associated with damaged underground conduit. If the conduit is crushed or punctured, it can expose the conductors to moisture, soil, and other contaminants, leading to corrosion and insulation breakdown. This can result in ground faults, short circuits, and other electrical problems that can create a shock or fire hazard. Damaged conduit can also compromise the grounding system, reducing its effectiveness in protecting against electrical shock. Furthermore, accessing and repairing conduit buried under a building can be extremely difficult and costly. Excavating the area around the conduit can be time-consuming and disruptive, especially if the building is occupied. The repairs may also require specialized equipment and expertise, adding to the overall expense. In some cases, it may be necessary to partially demolish or relocate sections of the building to gain access to the conduit. The code violation addressed here underscores the importance of careful planning and execution in electrical installations. Bypassing code requirements can lead to significant safety risks, financial burdens, and legal liabilities. It is essential to consult with a qualified electrician and obtain the necessary permits before undertaking any electrical work, especially when dealing with underground installations. Here are some additional points to consider. Firstly, proper grounding and bonding are crucial for the safety of underground electrical systems. The grounding system should be designed to effectively carry fault current back to the source, minimizing the risk of electrical shock. Bonding ensures that all metallic parts of the electrical system are electrically connected, preventing voltage differences that can create a shock hazard. Secondly, regular inspections and maintenance are essential for identifying and addressing potential problems before they escalate. Underground conduit should be inspected periodically for signs of damage, corrosion, or water intrusion. Any necessary repairs should be performed promptly to prevent further deterioration and maintain the integrity of the electrical system. Thirdly, accurate documentation of underground electrical installations is crucial for future maintenance and repairs. The location of all underground conduits, cables, and other electrical components should be clearly marked on as-built drawings. This information will help electricians and other workers to avoid damaging the electrical system during excavation or other construction activities. In addition to the NEC requirements, local codes and regulations may impose additional requirements for underground electrical installations. It is important to consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. When selecting materials for underground conduit installations, it is important to consider the specific environmental conditions. In areas with corrosive soils, it may be necessary to use corrosion-resistant materials such as polyvinyl chloride or a fiberglass conduit. In areas with heavy traffic or high soil loads, it may be necessary to use rigid metal conduit or concrete encasement to provide additional protection. Proper installation techniques are essential for ensuring the long-term reliability of underground conduit installations. The conduit should be installed at the proper depth, with adequate support and protection from physical damage. The backfill material should be carefully selected and compacted to prevent settling and damage to the conduit. Underground electrical installations should be designed to minimize the risk of water intrusion. Conduit joints should be properly sealed to prevent water from entering the system. Drainage should be provided to remove any water that does enter the system. Surge protection devices should be installed to protect against voltage surges caused by lightning or other transient events. Voltage surges can damage electrical equipment and create a fire hazard. Underground electrical installations should be protected from damage caused by rodents and other animals. Conduit openings should be sealed to prevent animals from entering the system. Rodenticides may be used to control rodent populations in the area. The location of underground electrical installations should be clearly marked to prevent accidental damage during excavation or other construction activities. Warning tape or other markers should be buried above the conduit to alert workers to its presence. Utility companies should be notified before any excavation work is performed near underground electrical installations. The utility companies can provide information about the location of their facilities and help to prevent accidental damage. Remember, it is never advisable to compromise on safety when it comes to electrical installations. Consulting with qualified professionals and adhering to established codes and regulations are the best ways to ensure the safety and reliability of your electrical system. It is important to remember that electrical codes are constantly evolving to reflect new technologies, safety concerns, and best practices. Staying up to date on the latest code changes is essential for electrical professionals and anyone involved in electrical work. The National Electrical Code is updated every 3 years, and it is important to have access to the latest version. Continuing education courses and professional development programs can help electricians and other electrical workers stay informed about the latest code changes and best practices. The NEC provides detailed guidelines for all aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. It is a comprehensive resource that should be consulted whenever electrical work is being performed. The NEC is not a substitute for professional judgment and experience. It is important to understand the underlying principles behind the code requirements and to apply them appropriately to specific situations. The NEC is intended to protect people and property from electrical hazards. Compliance with the code is essential for ensuring the safety of electrical installations. Failure to comply with the code can result in fines, penalties, and legal liability. Electrical inspections are conducted by qualified electrical inspectors to verify compliance with the NEC and other applicable codes and regulations. Electrical inspections are typically required for new electrical installations, renovations, and repairs. The electrical inspector will review the plans and specifications for the electrical work and will conduct a visual inspection of the installation. The electrical inspector may also perform tests to verify the proper functioning of the electrical system. If the electrical installation meets the requirements of the code, the electrical inspector will issue a certificate of compliance. If the electrical installation does not meet the requirements of the code, the electrical inspector will issue a notice of violation. The notice of violation will specify the code violations that must be corrected. The electrical work must be corrected and re-inspected before a certificate of compliance can be issued. The cost of electrical inspections varies depending on the size and complexity of the electrical installation. It is important to budget for electrical inspections when planning electrical work. Electrical inspections are an important part of the electrical safety process. They help to ensure that electrical installations are safe and comply with the applicable codes and regulations. When hiring an electrician, it is important to choose a qualified and licensed electrician. A qualified electrician will have the knowledge, skills, and experience to perform electrical work safely and in accordance with the code. A licensed electrician has met the requirements for licensure in their jurisdiction. Licensing requirements vary from jurisdiction to jurisdiction. It is important to verify that the electrician is licensed in your jurisdiction before hiring them. A qualified and licensed electrician will be able to provide you with a certificate of insurance. The certificate of insurance will protect you from liability in the event of an accident or injury. It is also a good idea to get references from previous customers before hiring an electrician. Check the electrician's references to make sure that they have a good reputation. Get a written estimate from the electrician before they start any work. The estimate should include the cost of labor, materials, and permits. Make sure that you understand the estimate before you sign it. Do not pay the electrician in full until the work is completed to your satisfaction. Following these tips will help you to choose a qualified and licensed electrician and to protect yourself from electrical hazards. Electrical safety is everyone's responsibility. By taking the necessary precautions, you can help to prevent electrical accidents and injuries. Remember to always turn off the power before working on electrical equipment. Use insulated tools and wear rubber gloves when working on electrical equipment. Never overload electrical circuits. Replace worn or damaged electrical cords and plugs. Keep electrical equipment away from water. Teach children about electrical safety. If you are not comfortable working on electrical equipment, call a qualified electrician. By following these simple safety tips, you can help to protect yourself and your family from electrical hazards.